Okay, so we're going to talk about another way to visualize functions, which is level curves. Okay, so we already talked about the graphs, and for the graphs, you look at z to be your function f of x, y, right? And then you go to the point x comma y in the xy plane, and then the elevation is determined by the value of the function at that point. Okay, and arrow diagrams is essentially you've got your domain, which is in the xy plane, and you actually use arrows to talk about the location of the value of the function at that point x comma y. Okay, so those arrow diagrams. The one that we really are going to concern ourselves with now is the method of the method that's called level curves. So level curves are very similar to traces. And what you're doing is you're looking at these equations here, f of xy equals k, right? So k is some constant. And k needs to be within the range of f, right? And what you do is you take all of these curves and you project them onto the xy plane. Okay? So let's see here. So you can see here from the figure, the relation between level curves and horizontal traces. So remember, horizontal traces, when you take your surface or your graph and you kind of dissect it, or you look at the cross section, imagine taking a horizontal slice, right? So now think about that intersection. In this case here, it looks like it's just going to be a bunch of circles, right? But now take all those circles, and project them onto the xy plane. So these are your level curves. The traces are all of these intersections here, right? So the traces are in blue, and the level curves are in pink, okay? So the level curves are just the traces in the horizontal plane projected down to the xy plane. Okay. So now one of the things you can notice is that it's easy to go from level curves up to the trace, because you can think of it as just taking the level curve and raising it up based on the value here. So I don't know if you can tell here, but it says k equals 20, right? And now this says k equals 25. So in your mind, you're thinking that you've got a circle here at k equals 20. And then at a height of 25, which is going to be even higher, you have a smaller circle, right? And then for at 30, you have even smaller circle. 35, you have even a smaller circle. So you're able to reconstruct based on the level curves, okay? Now, here's something to notice, that your surface is going to be steep where the level curves are close together, okay? Because what does it mean for the level curves to be close together? That means you're jumping up in value, but you're not going that far of a distance in the xy plane. And that's how you get steep. So imagine you're going up a hill, right? So this is a hill. Now, if you're walking and you walk, so you're starting here and then you end up here, your change in elevation hasn't been that much, right? But steepness would be, okay, now I start here and I walk just a little bit and my elevation changes like almost twice as much in half of the distance, right? So that's why this is steeper than this, right? Is because your change in elevation, the rate at which you're changing is greater. That's what makes it steep. Each of these level curves represents the same elevation. So if the level curves are close together, that means that you are changing elevation with very small change in the XY plane. Okay. Common examples: topography, maps of mountainous regions, right? So here, notice if this is a mountain called Lonesome Mountain, which side of the mountain is steeper? This side right here. That's going to be very difficult to walk up. Whereas here, Because do you see how the elevation changes from here to here versus here is changing from here to here, right? So the elevation change is very rapid on this side of the mountain compared to the elevation changes over on this side, okay? Level curves are constants of elevation above sea level. If you walk along the contour lines, you neither ascend nor descend. So what do we mean by that? We mean if you are standing right here and you walk along here, right, then you are not going up the mountain or going down the mountain. You have the same elevation. However, if you start here and you go up here, now you've increased your elevation, increasing. See, because now you're at 4,500, right? 46, 47, 48, 49, 5,000. And then you stay at 5,000. And then if you want to go downhill, okay, 49, 48, 47, 46, 45. Do you see? So staying along the same contour line means keeping constant elevation, okay? So we've got topographic maps is one example where level curves are used a lot. And another example is actually with temperature. So here, there's actually a special word for the level curves. They're called isothermals. So now remember, iso means equal or the same, right? Like an isosceles triangle, right? And then therm is heat.
It's 17:45.
Thank you. Therm is heat. So we're saying if you have same heat or equal heat, we're drawing the similar lines here. So notice. Down here with the purple colors, the cold colors, those are for cold regions, and then it's getting warmer. So you can have a map that is color coded, and then you've got the little indicators here to tell you what each isotherm means, okay? The temperature that it corresponds to. Okay. So let's see here. Isobars in this atmospheric pressure map. So ISO is the same, and then this is bar, which is pressure, like barometer, right? Barometer measures the pressure. So isobars here tell you where these are level curves that are telling you where you have the same atmospheric pressure. Okay. Let's use this contour map to estimate the values of f of 1, 3 and f of 4, 5. All right, so I'm going to go to 1, 3. So when x is 1 and y is 3, it looks like I am, so I'll say 1, 3. It looks like I am right here. Now, how do I estimate that value? I'm going to say that it is closer to, well, let's see. I should actually be able to. Okay, so if I were to, that's over too far. So I'm going to take the point in the middle, okay, which is here. Now, that point I would say is closer to 70, because this is 70. So I'm closer to 70. Let me erase that. Than I am to 80. So I would say maybe 73. So I'm going to say that's approximately 73. And now what about f of 4, 5? So let me do this with, this is essentially my ruler. So here I am, I'm at 4. Oh, they've got it up here for me. 4, 5. Okay, so for 4, 5, my intersection is right here. Now, the closest isotherm, so I've got that one, which is, how do I figure out what that is? I need to follow it. So that's a 60, and that's a 50. So I would say, Maybe I'm a little closer to 60 than I am 50, so not 55, but maybe 56. Okay. Ah, all right. It's pretty accurate there. Okay. Sketch the level curves. Now look, we already know this function. We expect it to be a plane, right? This is a linear function, z equals 6 minus 3x minus 2y, right? Now, if we look at the level curves for k equals negative 6, that means we'll have negative 6 equals 6 minus 3x minus 2y. So negative 12 equals negative 3x minus 2y. Now, if I graph this, this is just the equation of a line, right? Isn't that the equation of a line? So that would be 2y equals 12 minus 3x. So it'd be y equals 6 minus 1.5x. So it'd be something like that. And then I could erase and put in here that this is k equals negative 6. What do I get for k equals 0? So now I would have 0 equals 6 minus 3x minus 2y. So that means that 2y equals 6 minus 3x. So y equals 3 minus. Okay, so then I could take this same one and just drop it down, right? So now this is going to be 0. And then for k equals 6. And so in that way, right, so that's how to do the level curves. In that way, you get just a family of straight lines. Each line has the same slope, negative 3/2. The only thing that's changing is the y-intercept. Does that make sense? So the y-intercept is changing. And this one for k equals negative 6 would be like up here. So those are the two that we did. Okay? Now, this is just in line with a plane. Because if you have a plane, you expect your level curves to be lines, and you expect the lines to be equally spaced out because you're not having any change in the altitude, the rate that the altitude is changing, if you will. No part of the plane is steeper than another part. Right, that's part of it, is that it has the same direction throughout. Now let's look here, sketch the level curves of this function right here. So now the level curves are all going to be circles. X squared plus y squared equals 9 minus k squared, right? This is going to be the equation of a circle. Remember, k is a constant, so this is going to be your r squared. So they're going to be circles with the center at the origin, and what's going to change is the radius. So look at what's happening here. Notice that the curves, the level curves, are getting really close as you get close to 3. So we expect the graph to be steeper here, right? To be very steep here, and then to level out here. So imagine it being like steep, and then it levels out. Does that make sense? So it's very steep here, compared to here, it's not that steep at all. Okay, try to visualize the level curves being lifted up to form a surface, and that's exactly what we get. So we've got steep, it's very steep here, but the higher up you go in value, the less steep it becomes. Okay. And now we can do this example here, sketch some level curves of this function here. The level curves are going to be ellipses, right? So if we've got this is equal to some value of k, divide both sides by 4, so you have x squared plus y squared over 4 equals k over 4. So this is an ellipse because we can write this as y over 2 squared equals k over 4. So the ellipse with the center at 0, 0, and the y-axis is going to be the major axis is going to be like twice as long as the minor axis. So it'll be like long and then wide. like that. So there'll be ellipses like that. Okay, this is what we get pretty much. So now these level curves are drawn with a computer. And again, remember, the closer, if the level curves are really close to each other, that means that the graph is really steep, right? So looking at these level curves, the downside is we don't know the values. So you don't know if your if your surface is looking like that, or if your surface is looking like that. Does that make sense? Because we don't know, is the value at K here larger or smaller than the value at K here. But when you sketch it, right, if we had these level curves labeled, then we could tell, oh, okay, so out here is K equals 4, and on the inside is K equals 0.25. Right, so if that's K equals 0.25, remember K is the altitude. So now think of it like you're starting off with something that is, so the height of 4 is going to be wider than the height of 0.25. So that's how you get the shape. Okay? Elliptic paraboloid. Yes. And now just for giggles, we'll just look at the sketches of the Cobb-Douglas production function from before. The level curves are really helpful, especially in terms of estimating. So instead of having the chart with all of those numbers, right, that numerical chart, it's easier to see patterns if you're looking at the contour plot, okay, with the level curves. Okay, so these values here are the production level, so that's the P. Okay, and for some purposes, a contour map is more useful than a graph. So definitely, again, you're able to see trends easier. And in terms of estimating, the contour is very easy. And now we're just showing some computer-generated level curves. So notice here, even if you're not sure what's going on, you know that there is some, either you're going up, right? Either you're going up like that, or you're going down. Does that make sense? With these concentric holes. And then the fact that right here, they are very steep. The surface must be very steep at these points here because the lines are really, really close. Same thing here. The lines are really close, so the graph must be steep. And we would have to have labels in order to determine if this is a peak or a valley, right? But you've got those concentric circles, so you know that something is up. This is the same graph. Up top, these two have this as a level curve. You're just shifting it to be able to see, because here it looks like you only have one valley, but from this graph here we see that, right, one valley and two peaks, but we know that there are a total of 4 valleys and peaks altogether. So after rotating, you're able to see 1, 2, 3, 4. Okay, so very, very, very cool. And the next thing we'll talk about is functions of 3 variables.